Thanks, Brian. My proudest achievement is being Brian's friend. So how about that? Because it's not easy. That's what I'm saying. All right, cool. Well, we're talking about AI tonight. Who isn't talking about AI right now, right? So to start out with, I want to just talk about, first of all, I want to get my tech working. What screen is my mouse on? There we go. Okay, cool. Now I'm working. So I want to start out by talking about whether we think AI is a buzzword. And this is a tight hour if I do this talk for like a conference, but we're a small group here. So if we want to make this a little more conversational, feel free to interrupt as I'm going. I'm happy to field questions or have more of a discussion and change it up a little bit. So I think this is an important question to start with because I've been doing this 25 years or so. And in that time, there's been many of these things that have looked and felt kind of the way AI feels right now as far as the buzziness of it. And many of those things have kind of come and gone. And some of them are still with us in different forms. And so, it kind of begs the question for me, like, is AI worth talking about or is it just a buzzword? So I want to talk about a few projects here to see if you think that this technology is not working for me at all. We'll go old-fashioned style here. Okay. I want to talk about a couple of projects that I think are pretty interesting around AI. You might have heard of this one recently because this one had two people who were leading it just win the Nobel Prize for Chemistry like a week or two ago. So this is the AlphaFold project. It's run on Google's DeepMind AI. And this is a machine learning model that is used to help predict the shapes of proteins. And if you don't remember all the way back to high school biology, proteins are like the machines that make up most of the functioning parts of our bodies and every living thing's bodies. And they're made up of little building blocks that are called amino acids. When those amino acids connect with each other through chemical bonds, they connect in a way that we understand very well in chemistry. But what we don't understand is the complex shapes. You can see some in the background here on the side, the complex shapes that they form based on what other amino acids are around them and different charges and all kinds of complex three-dimensional aspects of the shape of those proteins. But these little proteins are sometimes called the machines of life because they're actually what makes life function and work. And so it's really important when you're thinking about disease, when you're thinking about drugs, to understand how these proteins work. And there's tens of thousands of them that have been identified by science, but very few of them that we understand the shape of because of the computational complexity of how many different shapes they could be. And so historically, what scientists have been doing is using supercomputers and traditional algorithms to try all the different likely scenarios and try and eliminate things and follow a path. And the computational complexity is just far too high for these complex proteins. But then they trained an AI on how these proteins work for the ones that we understand, and we're able to basically understand the shape of every protein that's ever been discovered within, like a 95% accuracy in, hours or minutes. And that is something that we thought we would probably never solve and has now been solved by AI. Another popular one in the media is the Tesla full self-driving. I am a Tesla owner, so I actually brought my car tonight if you want to go for a ride afterwards and see how AI drives. It's actually quite amazing. So a lot of the clickbait articles that you see will be tempting you to click on them with some outrageous claim. Some of them are substantiated and some of them aren't, of course. But what I've noticed is that it is actually quite amazing. What I've also noticed is that 98% good driver and 100% good driver is a huge difference. If you rode with me and I was 98% following the rules and doing what you expected, you'd probably be really uncomfortable. So that little gap there is a big gap, actually. But what I also noticed is that it was probably about 6 or 7 months ago, earlier this year, Tesla rolled out an update to this beta program that involved replacing about 250,000 to 300,000 lines of human-written C++ code with the machine learning model for a bunch of other scenarios that they hadn't done in the past to cover with the machine learning model. And what I noticed was instantly it drove much more naturally. So all of a sudden in all these scenarios that used to do kind of weird or awkward or robotic feeling things, all of a sudden it was feeling very human and natural in those same circumstances, and all thanks to AI replacing those 250,000 lines of code. And the last one that you might interact with on a more regular basis is your credit card or debit card. When you use this to go spend money somewhere and it gets denied for fraud, and your bank sends you a text message or a message in the app or whatever saying, hey, was this you? Or sometimes they'll actually call you. Hopefully this has been accurate for you sometimes, but of course sometimes it's not accurate. But Visa actually has published somewhat recently what their numbers look like for this. So they've rolled out to 200 countries a machine learning model that is doing, at the time that they announced it, about 76,000 transactions per second through this machine learning model. And what they found was that they were able to get results from this machine learning model that were about 300% more accurate than the human written code that they were using before for detecting fraud. And that machine learning model takes about 50 milliseconds to run on any given transaction. So when you put your card in the chip reader and it seems like it's taking a minute for the whole transaction to go through and you're like, what the heck is going on there? Only 50 milliseconds of that is actually the machine learning model running on that to see if that transaction is fraudulent or not. So pretty impressive, and pretty impressive results that obviously are better than what they were able to get with human written code. So with those stories in mind, I want to say that maybe AI is not just one of these other buzzwords that I've seen over the last 25 years. Now, there's a lot of buzzy stuff about it. I think anybody who tells you that next year your job will be replaced by this, is maybe on the buzzword side of the spectrum here. But is AI going to significantly change things? I think the answer is yes. Maybe the analogy that's best for it is the internet. We all knew that the internet was kind of a big deal when we first got on it and started using it, but we're really bad at predicting. If you ever go back on YouTube, you can see old stories from the news, from like local news and stuff. Even some national stories about the internet, the information superhighway, and surfing the net, and those types of things, what they're using at that time in the 90s. And the things that they predict for the future are somewhat ridiculous, and the things that they don't predict are also pretty major flaws. So I think that's kind of where we're at with AI. So for the rest of the talk today, I want to talk about what it is, when to use it, and how you can specifically integrate it into .NET development. Here's my contact info. I've also got a link down there at the bottom of the slide. I'll show this again if you're interested in getting these slides afterwards. You can get them from that GitHub link. And then also, we can just chat afterwards. You can reach out to me at all these places. I've also got this free consultation offer I give to anybody who comes to one of my talks. If you want to chat about AI or .NET or development or software or whatever, happy to do that. You can just put a time right on my calendar using that bit.ly link or that QR code over there. All right, so let's talk a little bit about what AI is first before we get into the details. So I spent a bunch of time, actually 26 years ago when I graduated from college, I actually had a computer science degree with an emphasis on artificial intelligence, which is kind of funny to think about in 1999, because pretty much in the years after that, I remember looking back at that and saying, well, that emphasis was useless. That's not going to be anything I ever use. And then boom, all of a sudden, all these years later, it finally kind of comes into its own. And a lot of that has to do with the technology improving, but more of it has to do with computational power of computers improving. We kind of knew, we talked about a lot of these things when I was in college. We just didn't have computers that could do these things at a useful level back then. But anyway, even with that background and knowledge, I went back to try and kind of understand, like, what are all the different kinds of AI that have developed over the years and how do they kind of organize? And what I discovered, first of all, is that you could organize them in all kinds of different ways. You could think about them based on how they evolved, which is kind of how I organized it here. Or you could think about it lots of other ways. So I went with this one. But basically up at the top of this tree, I've got artificial intelligence. And then I've got all the kind of different kinds that have evolved over the years. But the most important one that we're going to be mostly focused on tonight is a kind of artificial intelligence that's called machine learning. Or more specifically, you've probably heard it called deep learning, which just basically has to do with how it's doing learning, which is specifically neural networks. So when we're talking about this stuff tonight, a lot of what we're talking about is using some kind of a neural network behind the scenes to do deep learning or machine learning. So this is all kind of AI, but really in the day-to-day of what we're using AI for today, we're really down here under the deep learning category 99% of the time. All right, so let's talk a little bit about traditional algorithms versus AI algorithms. There's this old saying by Abraham Maslow, who you might have heard of if you ever took a psychology class because of his hierarchy of needs. But he also said this, if all you have is a hammer, it's tempting to treat everything as if it were a nail. And you might have seen this before when other hot technologies come out, all of a sudden everything is microservices, everything is containerized, everything is whatever, right? This is, I think, somewhat happening right now. The number of pieces of software or apps on my phone or whatever that I use right now that say they now have AI in them, that seems totally unnecessary to me, is getting a little ridiculous. But, you know, to bring this down to my own personal experience, our clients are coming to us right now and saying, we want to use AI. And we were like, great, we can help you with that. What are you thinking? And they're like, we don't know, we just want to use AI. And as if that wasn't funny enough, our team is also coming to us and saying, we want to do AI. And we're like, great, what do you have in mind? Like, what can we suggest to our clients that we might be able to, get them to do? And they say, oh, we don't know, we just want to do it. So it's kind of, everybody is just feeling this, which is why I came up with the talk title that I did for this talk. I think everyone is kind of feeling like, I think a lot of people are doing AI out there, and I feel like I'm missing out on something. So when would you actually use AI so that we don't end up going around having everything look like a nail? So AI is good at a number of different things right now, and I think this list will continue to expand as time goes forward. But right now, it's really good at things like image recognition. So if you have an image and you want to be able to create a description of it, a good example of this is if you have the ability for your users in your software to upload images and you want to get a description of it to know if it has certain things that you don't want users to be able to upload images of. Or if maybe you want a description of it so that you can put an alt tag on it so that it's more accessible for people who are using screen readers. All of that kind of stuff is now very easily possible with AI. It's really quite uncannily good at that. Text classification, natural language processing. This is stuff that AI is being used for all the time right now. You've probably done this before. In fact, even before the last year and a half when AI has kind of exploded, there were some websites where you could upload the software terms that you would get, and they would tell you what's in this and summarize it for you. That was basically using this type of natural language processing, speech recognition and synthesis. I think we've all seen the deep fakes and stuff where people's voices are stolen and reused to make them say things they never said before. Recommendation systems, if you use Netflix at home to watch videos and then you find it shocking how good it is at picking stuff that you might also like, that's an AI or machine learning recommendation system that's doing that. Anomaly detection, a lot of the new networking hardware is coming out with new software on it that is doing anomaly detection. Does this look like a network technician trying to connect to the network to do maintenance, or does this look like some sort of a organized attack on the network? That's the kind of thing it's good at. Predictive analysis, if this is how much our customers spend and we have all this data on how much the customers spend, then when we get a new lead, can we feed in some of that data about that lead and predict how much they might spend with us in the future? Pattern recognition. Of course, everybody knows content generation as one because of ChatGPT mostly. And then chatbots. Anybody gone to a website for an airline or a utility or anything like that and found themselves talking to what felt like an AI chatbot? Yeah. So, they're mediocre at this point, I would say. But you can make the argument that they're better than the menuing system. They're slightly better than the menuing systems that we had before. So I think those are evolving with AI as well. So when is AI not a good idea? If you have any kind of rule-based system, if you can come up with if-then type statements, that's a traditional algorithm right there, right? Deterministic rules, if you want to be able to always say when these inputs come in, these outputs go out, that's kind of the definition of deterministic, right? You do not want to use AI. You've probably seen before, if you've used anything like ChatGPT very much, that you can have two people talk to it and give it basically the same information and get very different quality and consistency of results. So deterministic is definitely what it is not at this point. I would say like 90% of the software that I work on every day at Trailhead is forms over data. It's basically just a way to enter data and then show that data to the right people at the right time. And there are ways you can enhance that with AI. You've probably seen this in all that software I was talking about that has like the smart AI buttons built into them. But I could think of like a forms application where you're entering product information, and one of the fields is maybe like a long form description, where that could be filled out by AI by looking at the picture that you uploaded or looking at all the other fields that you filled out and grabbing that information and creating at least a first draft of a description for you. But for the most part, the actual CRUD operations, the create, read, update, and delete stuff that you're going to do in a forms over data app, it's not going to be wildly helpful to have AI involved in that. Anything with transparency, where transparency is important, is pretty tough. At least right now, we don't really know how to look inside the AI machines that we've built and say, which are essentially statistical engines, and to look inside them and say, why did it give this answer and how can I debug it so it doesn't give that answer in the future? We really don't have that capability right now. They're too large and complex. Though it is interesting to note that a lot of computer scientists are working on the ability to do that. So maybe there's a day in the future where, as complex as these things are, we can actually kind of debug them. But right now, transparency and predictability are not on the table. And precision and simplicity. A lot of people don't realize how big these models are, because a lot of the ones that you interact with on a daily basis, like ChatGPT, are up in the cloud. And you don't realize that, if I ran that on my local computer, it would fill up the entire computer storage, and then it would go super slow because my computer is not powerful enough to run this thing, right? So if you're looking for it, keep it simple, then that's probably not a good fit for AI. I believe that in the future, pretty much all of our software is going to be kind of a hybrid approach, especially if you look at the way we've generated that software. So if you look at the developer or development team process and how much AI is involved in that, we'll talk about that more a little bit later. But I believe that if you look at that pretty much all software at some point in the future is going to be at least somewhat AI. And then when you look at the feature set as well, I think it makes sense for anything complex to have some amount of AI in it. So even though there's kind of these scenarios where AI is good and bad, what I'm kind of suggesting is that there are also hybrid situations. Maybe that's most situations where you'll do mostly, if you're doing forms over data, maybe you'll do mostly traditional algorithms with a little bit of AI sprinkled in there where it makes sense. All right, so let's jump into the actual tools that are available. I've organized these tools this way, basically by whether it's in the cloud or in code, and then how easy or complex it is to implement. So at the very top here, we've got the most simple things. And then as you move down, these things are getting more and more complex, all the way to building your own neural networks, which my guess is that most of us probably won't leave here planning on doing. But it is possible to do that. So we'll talk about all of these different things. And so we'll start with what I call AI as a service, or basically AI in the cloud. So for the Microsoft folks, since we're an Azure user group here, Microsoft offers quite a lot out in the cloud for kind of out-of-the-box AI functionality. I've listed probably like 50 or 60% of them here. There's another less often used 40% that I haven't listed. This all used to be called cognitive services. So you might have heard that name before. It's now called Azure AI Service. So if you see either of those names out there on the web, that name change happened probably less than a year ago. Is that right? Less than a year ago. Along with that name change, of course, Microsoft is good at a lot of things, but none other than renaming things. And so along with that name change came a bunch of other services that used to be part of cognitive services that have now either been removed, moved around into other services, or just renamed. So none of these have actually gone away, but I've just struck out the ones that have kind of moved somewhere else. Now, we don't have time tonight to talk about all of these. Hopefully you weren't scared that I was going to go through those one by one. So I'm just going to talk about a few of these before we move on to some of the other ones. But of course, we have to start with the one that everybody's probably the most familiar with, which is Azure OpenAI, or just using things like ChatGPT and other OpenAI language models. It's really easy to use these. There's a NuGet package that you bring into your .NET code called azure.ai.openai, and that basically gives you the ability to do either Azure OpenAI or make calls directly into OpenAI's APIs. That rolls right off the tongue, right? This is what the code would look like. It's very simple to use once you've got that NuGet package. If you're doing it in Azure, you're going to have a resource URI that you're going to get to like an endpoint, and you're going to get an API key. If you're using this type of authentication, you'll just authenticate with that API key, and you can give it whatever prompt you want and get back the completion back from the AI. As easy as that. You might be wondering, what are the differences between the OpenAI version of this API and the Azure AI version of it? Basically, they're functionally the same. There's a few things that are built on top of the OpenAI that you can only get through using it inside of Azure. First one is that are the same on both of these is that they don't use your data for training. So any of this data you're uploading into the cloud, giving it documents or chats or whatever, could be proprietary information that you don't want to now become public eventually. So by default, that's the case. You can also opt out of what's called data retention. So if you've ever used the ChatGPT UI, you've seen that they kind of keep like a history of your chats. You can think of this as basically the behind the scenes version of that. And you can basically say on either one of these APIs, you can say, don't do that. This is just give me the response back and don't remember anything. And then where you're really adding functionality inside of Azure is if you want to have this app running in a particular Azure region next to the rest of your application, or using some sort of private link or virtual network to connect to things on premise or in the cloud, or if you want to use your Azure AD / what's the new word for it? Entra ID, yeah. Then you can use that in Azure OpenAI, and OpenAI itself doesn't provide anything like that. So a little bit more like corporate level security. Okay, so the next one I wanted to just mention is the Azure AI Face APIs. This basically allows you to do a detection, recognition, and analysis of human faces. There's all kinds of different ways you could use this. You could do this to just detect when a human face is in the video. So for example, if you have like a Ring door camera type of setup, you've probably seen that it does like human detection. It'll tell you, hey, somebody's at the door. And that doesn't happen if like something blows past your camera, right? That doesn't look like a human, doesn't look like a face. So they're using some sort of face detection. You can do that. You can recognize specific people. So this is a little creepy, but you could also use it for good reasons, right? Like security. If you want to have the door to the office only unlock when people who work here put their face in front of it, you can do Face ID type of setup. You can even get like emotion and age and gender analysis of it. So is this person happy? How are they generally feeling right now based on their face? Maybe that feels even creepier. we are at a marketing company, right? So there's lots of things you could do with that. So lots of cool stuff, but it's really easy to use. Just like the other one, just like the OpenAI one, you just go create a resource in Azure. You'll get an endpoint and an API key. You come in here and create a new face client. And then in this example here, I'm taking an image from the internet and basically giving that to the face client and having it then loop over however many faces it's detected on that particular image and give me information about them, like age and gender guesses. So that's pretty easy to use. Another one that exists in Azure AI is the language APIs. This allows you to do things that used to be their own separate services, but are, like I was saying, have all been like subsumed and renamed inside of the Azure AI language. So text analysis, Q&A maker, and the language understanding service. And really, the language understanding service is the one that is the only one of these that I've really used before. But they're all potentially useful. So some of the things that you could do with this is if you're looking for named entity recognition, if you're looking for personally identifiable information, this could be useful in an application where people are uploading documents and you want to make sure that their phone number, their social security number, their whatever isn't in there, or if it is in there, it gets redacted or whatever. You can actually detect that with this AI language detection. This is one that I'm actually using. I wrote a Azure service that was basically going out to RSS feeds and pulling in blog posts and then detecting what language those blog posts were written in. And if they're written in English, then it's basically coming through and being used. And if it's written in another language, it's not. So that ended up being useful for us at Trailhead because we're trying to follow certain blogs that people are writing about, Microsoft technology or web technology or whatever. And some of these blogs are English only, and some of these, I should say, feeds are English only, and some of them are actually just like whoever wants to post something on there. And so, you end up with languages that I can't read, and most of our customers who are in the US wouldn't be able to read. And so we did this, and that ended up working perfectly. Sentiment analysis, that's basically like, are people happy? So you could take reviews and run them through there. And then summarization, that's one that you've probably used ChatGPT before, right? Like, what's this document about? Or what's Jay trying to say in this email? Something like that. So really easy to use this again. You go create that resource in Azure, and then you just create a text analysis client, use your endpoint and API key. In this example here, I'm basically taking some reviews that people have provided presumably for a product, and I'm looping over those and basically counting how many of them are generally negative, positive, or neutral about the product, and then I can kind of output that information. So I now know, generally how much people are liking this product, just based on, without having a human have to go read all of those reviews. All right, AI speech is another one that I wanted to talk about. This is a pretty cool one. Let's see if the audio works on here, on the TV. Is there a volume on this thing? Okay. Oh. So I don't know if this will work on the video recording, but it's not a huge deal. Same thing here. This example is assuming that this code is actually running on a particular device, because you see it getting an output, speaker output, which obviously would only work if you were running like a desktop application. But in this case, it's basically synthesizing some text, hello world, and it's saying it in a particular voice, which is called Jenny. And I have a little clip here from something, Azure AI has something called the Speech Studio, where you can basically try out all these different voices. There's hundreds and hundreds of voices, all for different languages and different regional dialects and so on. So there are, just Jenny alone has 15 different styles that she can speak in, and there's a whole bunch of American English speakers that you can choose from. I can't even remember how many. Let's see if this video works so you can hear.
Hello, world. I'm feeling great. Oh, no,
What's funny is that I've done this talk 5 times or something, and this is the first time that it sort of worked to do the audio. And some of those times there have been professional AV people in the room that were supposed to have it all working, but some reason like this part is easy and then the audio part is always hard. Okay, I'm gonna just turn that volume down, which didn't seem to do anything. Okay.
Hello.
Okay. The last one I wanted to mention is the AI translator. This is a useful one if you're trying to do automated translations. Obviously, automated translations are something that are of automated translation quality. So this translator is super useful if you're looking to translate a bunch of things really fast without hiring a translator. Obviously, keep in mind, you're not going to get the same thing you would get nuance-wise. So again, if you're going to use this, you're just going to use the text analytics client. In this case, I'm basically connecting to a couple, they're called SaaS URIs. These are basically like secure URIs to cloud storage resources in Azure with authentication built into the URI. So I don't have to like authenticate each of these documents individually in the blob storage. But basically those SaaS URIs just get me some document, okay? And in this code, I'm basically saying I want to translate that. So I'm inputting a document in French, and then I'm inputting a document and translating it to French. And then I'm outputting that document as a memory stream out to the console. So basically, I go grab that document and write out what I'm actually getting from it, translated to French. Pretty simple. Okay, so we've looked at some of the stuff that's available in Azure AI. So I want to talk about machine learning as a service. All of that stuff is basically like, okay, I have a specific thing I want to do. I want to recognize text. I want to recognize spoken voice. I want to recognize faces. This is if you want to build your own machine learning model. So this is more like I have my own data, and I want to train a machine learning model to use that data to make predictions, to do something. So Azure has a way to do this in Azure AI services called Azure Machine Learning. There's a bunch of different features in here, including something that's a pretty cool way to learn it called the Azure Machine Learning Studio. Has anybody played around with this? Yeah, okay. This is a great way, I think, to learn what's available in Azure AI. I don't know if it's exactly production stuff, but of course, all the demos Microsoft gives sort of like imply that it's production stuff. I think it's just where you get started. It also has a really cool feature that we'll talk about a little bit later on as well. That's called AutoML. This is basically assuming you are not a data scientist and that you cannot look at the data and use your years of statistics experience to decide exactly what machine learning type of machine learning model should be built off of this data to make the best predictions or the best whatever you're trying to do with it. AutoML will basically run through a chunk of your data. You can let it run for a certain amount of time or through a certain percentage of your data and say, tell me which of these are giving the best result for predicting this piece of data. So pretty cool. It'll tell you you should use this machine learning model on this data. There's a whole catalog. You can think of it as sort of like a NuGet packages of machine learning models that are available through here as well. They have this feature called managed endpoints. It's basically when you create a model in Azure ML, you can then basically say, I want this to be essentially like a REST API that's available for applications to use. This is kind of like the serverless ML, essentially. And then it has some responsible AI tooling so you can try and help predict and avoid things like bias in your machine learning models. Pretty easy to use it. You're going to bring in a NuGet package like you did with the other Azure AI stuff. And then in this example here, I'm basically logging into a particular API endpoint. I can't quite see my own code on there. I'm going to look on here. And then I'm getting some data that I'm going to give to it, which is basically temperature and humidity. 2 data points. And then I'm going to basically send that to the Azure endpoint, which might be this managed endpoint that I was just talking about here. I'm going to send that data to it, and it's going to give me back some sort of a prediction, presumably something about the weather here, since I'm giving it weather data. Maybe it's going to tell me whether it's going to rain or not on this day. And what's really great about this is that you could have a very large, complex machine learning model, and you could be hitting it from a mobile device, you could be hitting it from a web application, right? Anywhere that you want to use it, as long as you've got an internet connection, you've now got this machine learning model you don't have to deploy to every single device that you want to use it on, because they're able to connect to it remotely and make predictions off of your model. Okay, so that's machine learning in the cloud. Now we're going to shift over a little bit more into .NET and code specifically. So I want to talk about machine learning in .NET and also small language models. So we'll start with machine learning. There's a tool called, or a library called machinelearning.net or ml.net. It's a free open source package for .NET that's available as a NuGet package. It allows you to basically do all the same things that you can do in Azure ML, except you can do it hosted right directly inside of right inside of .NET code. And it also includes that AutoML feature. You can build models either through Visual Studio using something called the model builder that we'll look at in just a second, or you can build those models using the .NET CLI. So this will show you, this animation here is going to show you a little bit about what the machine learning tool, the model builder, looks like inside Visual Studio. So you can see when I have it installed, I can go to my project and add a machine learning model. I'm going to tell it what kind of thing I'm trying to do, sentiment analysis. I'm going to give it some data, tell it to train on it for 10 seconds. So it's basically looking at that data for me. It's then going to try a bunch of different algorithms, different machine learning algorithms on it, and see which one were the best for sentiment analysis. And when I finish, I can actually select that algorithm, have it generate the model, and then actually generate the code to use that model, is what we saw in the last step there. So just to go through it one more time, what kind of ML do you want to do? Sentiment analysis. Here's some data. We're going to train on it for 10 seconds. It's trying now all these different machine learning statistical models. And it's saying which one has the best accuracy. This one is like 65% accurate. So that's the one it's recommending. You basically say, go ahead and build that model, which you might notice comes out as a zip file. And the reason for that is machine learning models are large, and zip files make things smaller, right? In case you weren't familiar with them. So what's kind of cool about that is if you saw in that code to actually use this machine learning model, you're going to just include that zip file into your code as a resource. So it'll be deployed as a resource inside of your executable or DLL, whatever you're deploying from your .NET application. It'll be deployed basically as a resource inside of that file. And then you can just reference that file by name inside of your code like this. So you create a ml.net context and you load a particular model. And then you can ask that model to do predictive data. So I'm passing it the temperature and humidity data again. And it's giving me back whatever prediction, like rainfall prediction or whatever that it's set up to do. So now this is doing the exact same thing that we just saw Azure ML doing. What's different is that now the entire machine learning model is inside that zip file. It's now deployed with my application, which means if I'm writing a mobile app, say, or a desktop app here, now this can actually work without connecting out to Azure, without even having an internet connection. It can still make predictions off of this machine learning model. One other thing I wanted to mention is that ML.NET offers something called ONNX, or ONNX, which is the Open Neural Network Exchange. This is like a protocol / file format that Microsoft came up with. And basically, you could make the argument that Microsoft saw that everything in ML is happening in Python right now. And so they wanted to create something that would allow you to basically talk back and forth between Python-based technology that's creating ML and Microsoft technology that's creating ML. And so they created this format, but it's actually, as you can see from who's using it, it's something that you can use from all kinds of different common tools that you might do machine learning in. Like PyTorch, for example, is one of the most common ones, TensorFlow, and then the Microsoft, this is Cognitive Toolkit, but the machine learning, ML.NET is also in that list. So basically, all of these things can output their machine learning model in their proprietary format, but they could also potentially output it or translate it into this ONNX format. And then everybody else that knows how to speak ONNX can now make use of that machine learning model as well. So if you're out on the internet and you are familiar with some of these websites that have a bunch of models on them already and you want to make use of one of those, but you want to do it in .NET code, as long as you can find one of these that's built with one of these technologies, you can either find one that the publisher made that's ONNX compatible, or you could convert it yourself from the proprietary format into ONNX, and now you can use that inside of ML.NET or whatever other technology you're wanting to run it on. I also wanted to talk about small language models. When I gave this talk the first few times, this is the #1 question that came up. People were asking, what about using small language models? There's a bunch of them out there. These are the most popular ones that people are using right now. But the one I'm going to talk about is the Phi-3, which is the one that Microsoft has created. It's the Azure user group, right? But I also want to talk about that one because I think that one has some real benefits over the competition. So if you look at basically the quality of the model versus the size of it, and this is in billions of parameters here, you can see that the Phi model versions are kind of following this arc. And if you actually plot it out just above it, the theoretical limit, they're sort of approaching that theoretical limit for how good a small language model can be based on the number of parameters. And you can see these other ones are doing their best, but they're not getting there. They're either way too large to be good, or they're smaller, but they're not as useful for that size. So if you use something like the Phi-3 small, you're going to get something that is about the same size as the 8B version of Llama, but is, this is what, 67 or something like that on that quality scale, and that one is 77. So you're going to get an improved quality for size. So that's the other reason I'm talking about it. In .NET code, there's two ways to use these, to use Phi-3. Of course, it's ONNX compatible, so you can just download the ONNX versions of the Phi-3 model that you want to use, and then you can either install the NuGet package, that's the ONNX runtime, which allows you to basically access that code directly through the ONNX APIs, or ML.NET, which we just talked about, also has ONNX support built into it, so you can actually load that model in. As long as it's an ONNX model, it'll recognize that and it'll work automatically. Last thing is, if you want to use Azure to host it, Azure ML is also capable of doing that. All right. Second to last category I want to talk about is building your own copilots. That's what Microsoft calls these chat-based AIs, right? They call them all copilots. And the way that they recommend doing that is with the tool that was built inside of Microsoft to allow all these different teams that are building copilots for different Microsoft products to do it, and to do it consistently, and that's called the semantic kernel. So the semantic kernel is basically a tool that allows you to orchestrate different AI large language models and different other systems that are connected to it, and to create some useful larger chatbot out of it, or copilot. The way it works is it has 3 components: plugins, planners, and connectors. The way those are organized is basically the planners go inside the center here where it says semantic kernel. The connectors are just ways for you to connect to other systems. So those systems would be like REST APIs or databases or other proprietary systems, file systems, right? Like wherever your data is that you want to be able to connect to so that your AI can talk intelligently. I know Brian, your business partner, has done something with like this, but not with semantic kernel, with something else, right? I forget which tool he used. I don't know if you, yeah, Python, of course. And this is basically the .NET version of that. But you guys have all these documents and reports and things, and you wanted to be able to have a chat conversation and say, how's this customer's billability rate, or what's happening as far as revenue flow, or that kind of stuff, right?
Connected to our internal Google Drive folders that have some of our HR documentation. So someone could ask, for example, what's the PTO policy at Newsstream? We started into the Slack that this thing is tied to. Answer them. You have this much PTO, because actually we'll then look up the person who's asking the question and figure out who they are and how long they've worked at Newsstream. So you can put your own logic into the connectors at your data sources, which is saying. So
yep. So that's a perfect example. If you are asking your chatbot, how much PTO do I have, it has to know three things. It has to be able to know what systems it needs to connect to find the answer to that. So that's the planners that are here in the middle. It needs to be able to then connect to that system and get that and know how to get that particular data. That's the connectors. And then it has to basically know what that question means. What is PTO and what does a person having it mean? And that is basically the plugin. So that's adding functionality to semantic kernel that it didn't have before. You could think of this as like a library of functions, and that's connections out to data. It's a pretty cool process the way it works. If you want to look into this, Microsoft's got a bunch of great videos about it. But basically, when you send a prompt such as "remind me to buy milk when I go to the store" to semantic kernel, assuming you've set up all the correct plugins and connectors for it, it's going to look at that, and the planner is going to look at that and say, okay, there's a task in there, buy milk, and there's a calendar event in there when I go to the store. So those are the things that I kind of need to try and figure out how to do. It's going to then go look at all of the plugins that it's been given access to and say, is there anything that describes itself? And by the way, when you create these plugins, you actually put descriptions on, human readable descriptions on them. Say like, this is the this is the function that adds calendar events to people's calendar, or reminders to people's calendar, right? And so it's going to look through all of its plugins and try and find the ones that are the best match for doing the things that it needs to do. It's then going to create essentially this markdown language that it uses. Using a large language model, it's going to tell that large language model, here's what I want you to create, here's what I'm trying to do, here's all the plugins I know about, create me this markdown. So it's going to create all this markdown that's going to define what it's trying to do. And then that goes off to actually be executed by all the different pieces of code that you've written, like the plugins and connectors. And then hopefully in the end, you actually get a calendar invite that says, remember to buy milk out of this. Pretty cool. Using it is as simple as bringing in this semantic kernel, Microsoft.semantic kernel NuGet package. And then this example comes from the semantic kernel website. This is like a home automation plugin that they're proposing might exist. So you see here, each of the parameters on the functions, and then the functions themselves actually have attributes that are describing them in like human readable terminology. And that's not for humans, that's actually for the large language model. That's so that the large language model knows what that function does and what each of its parameters are, as well as like what it actually returns. And if you were going to use this plugin now, this is what it looks like to kind of set up semantic kernel in your startup code. So you're basically creating, Microsoft now uses this builder stuff for a lot of their applications. So you're creating a kernel.create builder. So that's your actual application right there. You're going to give it the model, the completion model that you want to use. So this is going to be, maybe ChatGPT running in Azure AI or something like that. And then right there where the blank is, this is where you would add all the plugins. So it comes with a bunch of plugins built into it. And if you want to write your own plugins, like this light plugin that says, a light is on or off and that kind of stuff. And then you can actually now ask this, I'm sort of forcing a prompt as if it was from the user here, what lights are currently on, and it can now go and it can check the status of all your lights using this plugin that you wrote that is, got some underlying connection to some API or whatever. So pretty cool. The last one I want to show is building neural networks. This is the one I assume none of us are probably going to leave right away and do. But there's this, just so you're aware, this exists. If you want to create your own or play around with this, there's something called Cognitive Toolkit, or for some reason it's shortened CNTK. And you can create basically all kinds of different neural networks. So the most common simple type, these feed-forward ones, the recurrent neural networks for a little more complex tasks, and then the ones like this that are used for like image recognition and that sort of thing that are called the convolutional neural networks. All of these things you could actually build inside of Cognitive Toolkit. And this is kind of what the code looks like. This is an extremely simple example. This is a 2-layer convolutional neural network that's been built for the purpose of image classification. So you can kind of see the code is split into 2 different chunks here, and that's the 2 different layers being set up, all the different parameters for how the layers are supposed to work. Obviously, this is getting down into the like pretty deep computer science level of things, but this basically sets up a very simple version of one of these right here. Okay, just a few other things that if you want to look into them more, if you want to look into them, I didn't have time to mention them. One of them is TensorFlow. This is another machine learning platform that you can use in .NET, TensorFlow.net, and then Accord.net is also another machine learning model. Both of these, by the way, support ONNX. So if you're interested in running machine learning models, you can use ML.net, or you could look into these 2 technologies as well. So just kind of remember when you're working with AI that the junk in, junk out, right? So if you're doing a machine learning model and you have bad data, that your predictions are going to be bad. There's also ethical considerations to be had. If you're training it off data that has been created by humans in some sort of a biased system, that bias is probably going to be trained into the machine learning model, and it's going to continue that bias. Also remember that you've got a real black box on your hands when you create any kind of machine learning model. You really can only tell what the inputs and outputs are. It's hard to say what's happening inside, which means if you don't like what's happening, it's kind of hard to debug. Scalability is tricky, and maintenance and monitoring are tricky. You have to actually train a new machine learning model, deploy a new machine learning model. So that can be a little bit of extra work. So just to kind of sum up, I think AI is something that is actually transitional that's happening right now. You can either do an all AI application, or you can integrate it into existing traditional applications. It's only good at certain types of problems, so don't try and use it for the things that it's not good at. Got a couple different ways to do ML, either in the cloud or in .NET directly. If you want to do small language models, Phi3 is a good option, and you can use ONNX to do that. Semantic kernel if you're trying to build your own copilot and connect it into your own systems. And then Cognitive Toolkit if you're trying to show off. So that is the end of my content. Thanks.